Welcome back to Thermodynamics Class 3. This is video 3. In the previous one, we talked about the steam tables, took a little bit of a tour through them. Let's take a look at how to use them, or an important way that we'll be using them often. So this is when we have two phase states that are taking place, which always means that we're inside underneath this dome. And you could kind of take a look at the idea. I've written it out here already. You could write this in our notes, but I've written it out onto this presentation here. If you had the total volume for a given chunk, it's going to be comprised of the liquid and the vapor volumes, right? So anything in here. And if we wanted, we could make these into specific volumes by multiplying the amount of mass for the liquid times the specific volume for the fluid, the liquid, and then likewise for the vapor. And I don't know why we're having liquid and fluid and vapor and gas. This should be gas too, and this should be fluid here. I don't know why they're being weird like that. So we know because the specific volume is the volume divided by the mass. You could then break it down this way right here and get like this common denominator thing going on. And so what we have is we could have percentage or a ratio of the liquid. All right. So this is, oh, excuse me, I'll take it back. You have this thing called X. And what is X? I'll write it down here. Well, I'm going to turn this thing back into a pen. Make this into a pen. Okay. So X is going to be mass. We'll go mass. The mass of the vapor divided by the total mass, right? So it's the percentage vapor, right? It's going to be something between 0 and 1. And so here's a good way to remember it. It's X is 0 over here, X is 1 over here. That means it's completely a vapor. So if you want to find what the specific volume is, and this is just a for instance, because if you recall from the previous video, we had 4 properties that we could find from those steam tables. We had specific volume, we had internal energy, we had enthalpy, and we had entropy, and they were all per mass, right? They were all lowercase letters that represent them. So what we do is we take the fluid and we add to it this X that we have multiplied by the difference, right? So if you'll recall in those columns, let's see if we come back up to this right in here. For all of these, we had the VF right here, and we had the VG, but in between here had the VFG. That VFG is the difference between this column and this column. So we don't actually really even need that column because we are always using the fluid as the reference, multiplying X times that difference right there. So this is a really important equation. We'll note that we'll also do the same thing here later on with the internal energy. We'll have UFG. We'll also do the same thing with enthalpy. You get the idea. It's a thing that we'll do often. So maybe we want to let's go FG. Okay, I didn't bother writing it for the S in there. Anything else we want to mention right in here? No. So maybe I want to go ahead, and it's enough time. Should be fairly fast. Example 2.1. Yes, okay. So let's go ahead and do this example. Show it in action. So it's useful. Okay, let's see. I'll get this in here so I can maximize the width. Where we have determined the phase for each of the following water states using the tables and appendix there. So I think I'm only going to do one of them. Well, let's see how it works. Okay, so we have 120 degrees Celsius and 500 degrees, 500 kilopascal, excuse me. And so that is actually, trying to think right here as I'm looking at this, 120 and 500. I'm going to pause for a second. I'm getting disoriented. Okay. Not sure what happened. Failed to pause. Please try again. I think, oh, I see. So we just had a bunch of blank space. So I'm going to continue this in another video. I'm sorry, I apologize.